Good afternoon, students. Welcome to the lecture 3 of Unit 1, Refrigeration and Air Conditioning. So in the last two lectures, I have given the basic introduction of all units and also the wide applications of refrigeration and air conditioning. Hope you understood the concept. Now in this session, I want to discuss about the refrigerant, the units and coefficient of performance and heat pump, air cycles and their types. Okay, we'll start into the class. So in the last class we have discussed about the applications. Today in this class we'll discuss about the definitions and the concept. So the refrigerator and refrigerant. So in a refrigerant we use some sort of chemical substance. Hello. Hello. A refrigerator is a reversed heat engine. A reversed heat engine or a heat pump. So in the thermal engineering you have observed about the reverse heat engine, heat pump and also in the heat treatment process. Yes. Yeah. Okay. So a refrigerator device or heat pump which takes out the heat from the cold body and delivers it to the hot body. So the refrigerant is a heat carrying medium where it is used in a refrigeration cycle and absorbs the heat from the lower temperature and delivers it to the higher temperature. So a simple example is your fridge. Outside in your shops you are having a cool drinks fridge or your ice cream vendor, that is a quality ice cream Uncle John, where is having a mobile transportation vehicle. So a refrigerant is a chemical which absorbs the heat from lower temperature. Lower temperature అంటే ఏంటి? The place where it is in the fridge. తెలుగు. సో మీకు తెలుగులో ఫ్యాకల్టీస్ చెప్పి అలవాటు అయిపోయిందమ్మా. Still you came to third year, still you are asking to teach in Telugu. But improve your language. This is English medium Chaparral Engineering College. I try to teach in Telugu in some cases only, not in all classes. So a refrigerant అనేది ఒక chemical substance which is used in a refrigerator and absorbs the heat from the lower temperature. Lower temperature అంటే ఏంటి? Take a fridge. Temperature fridge లోపల ఫ్రిడ్జ్ బయట డిఫరెన్స్ ఉంటుంది. ఫ్రిడ్జ్ లోపల లోయర్ టెంపరేచర్ ఉంటుంది, ఫ్రిడ్జ్ బయట higher temperature ఉంటుంది. So a refrigerant is a chemical substance which takes the heat from the fridge and delivers it to the outside atmosphere. అందుకే మీరు ఒక ఫ్రిడ్జ్ వెనకాల వెళ్ళి నుంచుంటే ప్రజెంట్ హై టెక్నాలజీ ఫ్రిడ్జెస్లో బ్యాక్ సైడ్ మీకు హీట్ కనబడదు, మీకు ఒక షీట్ క్లోజ్ చేసి ఉంటుంది. బట్ ఇఫ్ యూ సీ నార్మల్ ఫ్రిడ్జ్, at the bottom of the fridge you can observe, you can feel some heat, right? మీ ఫ్రిడ్జ్ లోపల కూల్గా ఉంటుంది, వెంటనే బయట హాట్గా ఉంటుంది. అంటే లోపల ఉన్న టెంపరేచర్ని ఇంకా కూల్ చేస్తూ రెఫ్రిజరెంట్ అనే మీడియం ఇట్ అబ్జర్వ్స్ ద హీట్ and delivers to the outside atmosphere. That is nothing but a refrigerant. The total amount of heat being rejected to the outside body consists of two parts. The amount ఎంతైతే రిజెక్ట్ అవుతుందో అవుట్సైడ్ బాడీకి టూ పార్ట్స్ లోపల విభజిస్తాం. The first one is the heat extracted from the body to be cooled. ఏదైతే ఒక ఆబ్జెక్ట్, ఒక నార్మల్ వాటర్ బాటిల్ తీసుకొని ఫ్రిడ్జ్లో పెడతారు, ఒక వెజిటబుల్స్ తీసుకొని ఫ్రిడ్జ్లో పెడతారు, అప్పుడు వెజిటబుల్స్కి నార్మల్ టెంపరేచర్ ఉంటుంది. ఫ్రిడ్జ్లో పెట్టినప్పుడు వెజిటబుల్స్లో ఉన్న నార్మల్ టెంపరేచర్ రిఫ్రిజరెంట్ అనేది ఎక్స్ట్రాక్ట్ చేసి ఇట్ సెండ్స్ అవుట్ సైడ్. అర్థమైందా? నెక్స్ట్ సెకండ్ పార్ట్ ఈస్ ద హీట్ ఈక్వలెంట్ టు ద మెకానికల్ వర్క్ రిక్వైర్డ్ for extracting heat. Second, what is the second part? Mechanically, the process of extracting the heat from the body. So like this, the amount of heat is divided into two parts. One is extracting from the body and mechanical work required for extracting. Next, refrigeration cycle. In refrigeration system, the heat is being generally pumped from lower level to the higher level. Like ఇక్కడ చెప్పుకున్నట్టు lower temperature to the higher temperature and rejected at the temperature. అంటే లోపల నుంచి తీసి బయటకు వచ్చిన తర్వాత then it dissipates the atmosphere. This rejection of heat from lower level to the higher level of temperature can only be performed with the help of external work according to the second law of thermodynamics. So this is the basic concept of refrigeration cycle. So whatever the heat is coming from an apple, cool drink, any object inside the fridge, it is taken out to the external body and it is dissipated to the atmosphere. That is external work done according to the second law of thermodynamics. Keep this in mind. Next. Now if you see the typical single vapor compression refrigeration system, a line diagram. For example, మీరు ఒక ఏసీ మెషిన్ కానీ ఫ్రిడ్జ్ ఆర్ సమ్ అదర్ షాప్స్లో ఉండే ఫ్రిడ్జ్ దాని మాన్యువల్ ఓపెన్ చేశారంటే అంటే బ్యాక్ సైడ్ మీకు ఎలక్ట్రికల్ వైరింగ్ అంతా ఒక లైన్ డయాగ్రామ్ ఉంటుంది, ఎలక్ట్రానిక్ సిస్టమ్ అంతా ఒక లైన్ డయాగ్రామ్ ఉంటుంది, కంప్రెసర్స్, మెకానికల్ సిస్టమ్స్ అన్న ఒక డయాగ్రామ్ ఉంటుంది. సో లైక్ దిస్ యూ కెన్ సీ ఏ chart, a figure like this. See here is a vapor compression refrigeration. Condenser may be water cooled or air cooled. So మీకు basic compressor, condenser, evaporator ఇవన్నీ మీకు ఆల్రెడీ మీకు ఐడియా ఉంది. So I will not give total definitions, but I'll give the information how it works. Okay. See here, the cold air, the warm air, right? So when a warm air is entering, the fan takes the warm air, so it is passing to the evaporator, vaporizing to compressor mode. From the compressor, the vapor is going to the condenser and get condensed in a liquid form and passing to the expansion valve. In the expansion valve, So the liquid is converted into liquid and vapor. Then it is passing into the evaporator. Thereby cool air is coming outside. That is the process of refrigeration. So if you see the air condition, car lo, bus lo, me house lo, the AC outside cabin ki you are having a delivery duct or a small pipe. మీరు ఏసీ ఆన్లో ఉన్నప్పుడు లేకపోతే ఏసీ బస్సెస్ హైవేస్ మీద వెళ్తున్నప్పుడు మీకు బ్యాక్ సైడ్ వాటర్ కారుతూ ఉంటుంది. చూసారా, అబ్జర్వ్ చేశారా? లేదంటే మీ ల్యాబొరేటరీస్ హౌస్ రైట్ సైడ్ బీ బాక్స్లో నుంచి పక్కన ఒక చిన్న పైప్ ఉంటుంది. ఫ్రమ్ దట్ పైప్ water is coming out. What is that one? The moisture content present inside the room. So it will extract the liquid and it is sending outside. Okay. Now, a refrigerator is a reverse heat engine, runs in a reverse direction by the means of external aid. External aid means some source which is used to give the supply to the refrigerator. Next, each type of refrigeration system used for producing the cold must have the following units. So the four basic units for refrigeration are: first one, low temperature thermal sink, to which the heat is rejected for cooling the space. So ఒక స్పేస్ లో నీకు కూల్ రావాలంటే టెంపరేచర్ ఎంత ఉండాలి? లో టెంపరేచర్ లో ఉండాలి. విత్ ద మీన్స్ ఆఫ్ థర్మల్ సింక్. Second basic unit is by the means of extracting the heat energy from the sink, raising its level of temperature before delivering it to the heat receiver. So for example, if you see the thermocol sheets, so ice cubes ఉన్నాయి, అది కరగకుండా ఉండాలంటే ఏం చేస్తారు? ఒక థర్మోకోల్ బాక్స్ లో పెడతారు. So thermocol box acts as a medium, right, which absorbs the heat and maintains the ice in a cool form. Okay. Third unit, a receiver is a storage to which the heat is transferred from high temperature, high pressure refrigerant. So a receiver, third one is a heat receiver is a device which is used to store the energy coming from the extracting device. Next, fourth one, by the means of reducing the pressure and temperature the refrigerant before it returned to the sink. Just malli oka cycle. So by reducing the pressure and temperature of the refrigerant before it returns to the sink. The processes of the cycle are: first one is evaporation antunnam, second one is compression antunnam, third one condensation, fourth one is expansion. So see here, evaporation process jarugutundi, ikkada compression process jarugutundi. So this is cycle 1, this is cycle 2, this is cycle 3, this one is a cycle 4. So keep this figure in your mind. ఒక్కొక్క టెక్స్ట్ బుక్స్ లో ఒక్కొక్క లా కనిపిస్తుంది, but that figure is this one only. You can draw a box wise or you can show in a representation of figure type. So గుర్తుపెట్టుకోండి, evaporation, compression, condensation and expansion. Before reversing the heat cycle completely by changing the working agent, the refrigeration cycle is obtained. Okay, so how? Just see the next slide. Coming to the unit of refrigerating capacity, Chari. Chari, I hope you are understanding
Sir.
Telugu. Try to understand.
Okay, sir, I understand.
So if you have any doubt, just chat.
No, sir.
The simple definitions. Standard unit of refrigeration. Vogue ante simple language lo is referred as ton or simply ton denoted by TR. It is equivalent to the production of cold at the rate of heat is to be removed from US ton of water at 32 Fahrenheit to freeze it to the ice at 32 Fahrenheit in 1 day or 24 hours. ఇదంతా వదిలేసేయండి, నథింగ్ మీకు అవసరం లేదు. Just 1 ton is equals to 1 into 2000 lb into 144 divided by 24 hours into 24 hours or 1 day. That is equal to 12,000 BTU per hour or 200 BTU per minute. So simply we can say 1 TR is equals to 12,000 BTU per hour, means 12,000 divided by 3.968. That is equals to 3.024.2 kilocalories per hour. So that is a unit of refrigerant. Simply we are saying them as 1 ton. So మీరు ఫ్రిడ్జ్ కొని ఏసీ కొనేటప్పుడు దే విల్ ఆస్క్ మీకు ఎంత కెపాసిటీలో కావాలి, 1 ton, 1.2 ton, like that. Then you have to understand that he is asking about the capacity, how much we require. Understood? So if you come to the definition of that, refrigeration. So what it is saying, 1 ton of refrigeration is the amount of heat extracted or produced by melting 1 ton of ice from 0 degrees in 24 hours. Therefore, 1 TR is equals to 50.4 kilocalories per minute. Okay. Or if you convert into kg, heat fusion of ice is equals to 336 kilojoules. 336 kilojoules. Okay. Kilojoules per kg. So that is a simple definition of 1 ton of refrigeration. So what is the definition again? I am telling you. It is amount of heat produced or extracted by melting 1 ton. By melting 1 ton of ice at 0 degrees in 24 hours. So if you see the pH diagram for a pure substance, take any substance, any solid substance. So this already you have concept in thermal engineering. So this is a y-axis pressure, x-axis is entropy. So get solid line, a saturated vapor line, right? So here the medium is in solid state. Here the medium is in solid and gaseous state. So in between the saturated solid line, you are having a saturated liquid line. So here both solid plus liquid you are having. Later after this line, totally it is in liquid state. So solid, solid plus liquid, liquid, liquid plus gas. Understood? So the line after the liquid's phase is nothing but liquid plus gaseous state. See here, the dotted line shows the constant temperature lines, constant entropy lines. The solid gives a constant entropy line. See the line. This one is a saturated vapor line where it is placed from liquid state to the solid gaseous state. There is a pressure entropy diagram for a pure substance. So when you get a question, you have to draw the diagram, pH diagram for a pure substance. TS, temperature diagram for a pure substance. So here, if you see the x-axis temperature and enthalpy in x-axis, the same solid line on the y-axis, x-axis solid plus gaseous. In between those two, saturated solid line and saturated liquid line, solid plus liquid. So the line is the phase is changes like this, going up and decreasing down. So here the medium is transforming from solid to liquid, then liquid to gaseous form. So the critical point is at the highest point where it is located, right? So దీని తర్వాత ఏమొస్తుంది? Totally gas. So see here, solid plus liquid, liquid plus gas, finally gas. నుంచి తీసుకున్నప్పుడు solid plus gas, again gas. So this is a temperature enthalpy diagram for a pure substance. So these two diagrams are very simple to learn. By heart చేయాల్సిన అవసరం లేదు. P ఇక్కడ పెట్టండి, H ఇక్కడ పెట్టండి. Solid liquid, liquid, solid liquid gas, liquid gas. So the critical point is at this point. Next definition is refrigerator. What is the meaning of refrigerator? The transfer of heat from lower temperature to the higher temperature requires a special device called refrigerator. So see here, the work input manam istunam. R is a work input what we are giving. So here lower temperature heat is absorbed lower temperature reservoir. అంటే ఇక్కడ ఒక ఆబ్జెక్ట్, ఈ ఆబ్జెక్ట్ లోపల heat is absorbed, QL, latent heat is absorbed and it is passing through the working process and is rejected to the high temperature reservoir. That is, heat is rejected. అంటే మనకి టెంపరేచర్ అనేది ఇక్కడ నుంచి ఇట్లా బయటకు వెళ్ళిపోతుంది. You can draw the diagram at any way. So that's why if you see the blue color indicates cooling, high temperature reservoir indicates hot. So దీని బేసిస్ తీసుకొని యువర్ డైరెక్టర్ మిస్టర్ రాజమౌళి RRR మూవీ తీశాడు అంతేనా? బ్లూ ఈస్ ఐ థింక్ రామ్ చరణ్, NTR is red I think. Now the objective of the refrigerator is to remove the heat QL from the cold medium and getting QH to the warm medium by the use of heat pump. Okay, now the coefficient of performance R is equals to desired output by కావాల్సిన input. Okay, that is equal to cold effect by work input, that is QL divided by W net. So ఈ ఫార్ములాస్ ఇంగ్లీష్లో అయినా తెలుగులో అయినా ఒకటే ఉంటుంది, just by heart it. COP of R is equals to QL by W, work input, total net work input. వాట్ ఇస్ ద మీనింగ్ ఆఫ్ హీట్ పంప్? మీకు థర్మల్ ఇంజనీరింగ్లో యువర్ హీట్ సబ్జెక్ట్లో వచ్చి ఉంటుంది. Heat transfer subject or thermal engineering subject. Now, a heat pump supplies means gives the heat to the high temperature region from lower temperature by giving work as input. అంటే మనం ఏదైతే ఇన్పుట్ వర్క్ లాగా ఇస్తున్నామో the heat pumps gives the heat to the high temperature from the lower temperature. అంటే మీరు ముందు స్లైడ్స్లో ఆర్ అనేది మనం హీట్ పంప్ అనుకుంటే హీట్ పంప్ ఏం చేస్తుంది, లోయర్ టెంపరేచర్ నుంచి హీట్ తీసుకొని హై టెంపరేచర్ దానికి పంపిస్తుంది. ఇక్కడ నుంచి మనం వర్క్ ఇన్పుట్ చేస్తున్నాం, అదే ఇక్కడ మనం చెప్తున్నాం. హీట్ పంప్ సప్లైస్ ద హీట్ ఫ్రమ్ హై టెంపరేచర్ region from a lower temperature by giving work as a input. Heat pumps and refrigerators are essentially the same device. They differ in their objectives మాత్రమే. ఓకేనా? Now see here the what heat pump. ఇది cold environment, ఇది warm environment. HP అంటే heat pump. So QL, heat is extracting. Now heat is sending desired output. Right? So this is a left side ఉన్నది required work input. నువ్వు లెఫ్ట్ అయిన ఫిగర్ వేయి, రైట్ అయిన ఫిగర్ వేయి. నువ్వు ఎగ్జామ్లో వామ్ కింద వేసినా కోల్డ్ పైన వేసినా నథింగ్ హ్యాపెన్స్, బట్ ద డైరెక్షన్ షుడ్ బి ఇన్ వన్ డైరెక్షన్. దేర్ ఫోర్ హీట్ పంప్ చూడు, కోఎఫిషియంట్ ఆఫ్ performance HP is equals to desired output by input QH by work input. So COP of HP is equals to COP of R plus 1 for fixed values. Next, coming to the air cycle refrigeration. So till now we have discussed about the definitions. Okay, now so generally in the thermal plant, that is the devices. So we are having two types of devices. One is work producing, other one is work consuming. అంటే మనం వర్క్ చేస్తున్నాము, వర్క్ని స్టోర్ చేస్తాం, వర్క్ ప్రొడ్యూస్ అవుతుంది. Next, in the work producing, what you are having, so the work producing means heat engine. Example, internal combustion engines, gas turbines, steam turbines. ఈ ఇంటర్నల్ కంబషన్ ఇంజన్, గ్యాస్ టర్బైన్, స్టీమ్ టర్బైన్స్ ఏం చేస్తుంది, హీట్ని ప్రొడ్యూస్ చేస్తుంది, అంతే కదా. సో మీరు ఒక టేక్ యువర్ బైక్ ఆర్ కార్, యు ఆర్ హ్యావింగ్ internal combustion engine, SI engine or 4-stroke engine, CI engine. There you are producing the heat. So if you see in some big engines, you are having a flywheel at the back side. So at that flywheel, what you are having? So in the flywheel side, you are storing the energy. Okay, you are storing the energy. Check, hello. Hello. Yes. Okay. So what we are discussing in the thermal plants, you are having two types: work producing machines, work consuming machines. So work producing means a heat engine like internal combustion engine, gas turbines, steam turbines. ఇవన్నీ హీట్ని ప్రొడ్యూస్ చేస్తుంది. in order to do the other applications. Whereas work consuming objects like heat pump, examples ఏంటి? Fridge, compressors, pumps, etc. So these are వర్క్ కన్జ్యూమింగ్ డివైజెస్. అంటే ఫ్రిడ్జ్ ఏం చేస్తుంది? కూల్ని హోల్డ్ చేస్తుంది, రైట్? సో లైక్ దిస్ ఇన్ ద థర్మల్ ప్లాంట్స్ యు ఆర్ హ్యావింగ్ two concepts. One is work producing, other one is a work consuming, right? Next. So if you see the refrigeration, generally it should be of 35 degree Fahrenheit. 35 degree Fahrenheit. So the cooling of air